Hey, welcome back to our Honors Geometry playlist. On this video, we're going to talk about some multivariable sine, cosine, and tangent problems dealing with angles of elevation and depression. So first thing we should do is check out our diagram, draw some triangles. In this problem, we've got two swimmers and a diver. One swimmer is looking up at an angle of elevation of 40 degrees. Another swimmer is relaxing on their flotation device. They're looking up at an angle of elevation of 30 degrees at our diver. Now, what we're wanting to find out is how tall is that diving board? I want to know how tall is that diving board if these guys are 5 feet apart. So what I need to figure out first is, what are my variables? I got x for the height of the diving board, but I need two sides. I've got to figure out two sides in order to have a trig ratio. So the only other side I have this relationship on the bottom side of my triangle. So I'm going to call that y. I'll have to introduce a new variable. And if this is y, then the other guy is 5 feet farther away. That would be y plus 5. And if this is the first time I've seen a multivariable trig problem, I'm going to be a little bit confused, right? This is a scary problem. There's two variables. I don't know what to do. But luckily, if we follow the same process that we always would, you're going to end up at the right spot. So first thing we should do is identify what sides we have. I have an opposite, and I have an adjacent. And I have an opposite, and I have an adjacent. So I have the tangent of 30. The tangent of 30 is the opposite over the adjacent. And here the tangent of 40 is equal to the opposite over the adjacent. Now, again, if this is the first time I've seen one of these problems, I'm going to feel kind of confused, right? I won't quite know what to do. But think back to what we would always do if I had a problem like this. If this were, x and 7 or 2 and y, what would we do there? Well, we would cross multiply to solve for our variable. We'll do the same thing here. Remember to distribute to both parts. So y times tangent of 30 plus 5 times the tangent of 30 equals x. And this is the tangent of 40 times y, or y times the tangent of 40, equals x. And what do you notice about our equations here? What do they have in common? Well, they both equal x. So if this stuff equals x, and this stuff also equals x, then I can write an equation where they equal each other. I can say that y times the tangent of 30 plus 5 times the tangent of 30 equals y times the tangent of 40. Okay, and this looks very scary. I'm not really sure what to do here. What I want to remind you all is that these tangents, or 5 tangent 30 or tangent of 40, those are just decimals. They're numbers, right? So that might look scary, but if they're just numbers, it's kind of like a problem where I have 2y plus 8 equals 4y. And I know how to solve that. I would combine my like terms and solve for y. Well, it's a similar problem here. And I'm going to demonstrate that with some decimals. So this is actually 2.89 approximately. Tangent of 30 is 1 over root 3, or root 3 over 3, which is 0.577y. And then the tangent of 40 is 0.839y. So what would I have to do here? I would have to subtract this from both sides. So let's do that. I'm going to subtract that from both sides. Let me erase. So tangent of 40 minus tangent of 30 is 0.262y. And then 5 tangent of 30, 5 times the tangent of 30 is 2.887. So if I divide that by 0.262, I'd get y is approximately 11.02 feet. But unfortunately, I'm not trying to solve for y. I mean, it's nice that I've got that, right? It's helpful, 11.02. The problem is I'm not solving for y, I'm solving for x. So now I'm back at a one variable. Now I've got that the tangent of 40 equals x over 11.02. And I can solve that. And x would be equal to 9.245 feet. So it's a 9.25 foot tall diving board. All right, let's try another one. Again, you got to draw two triangles. One triangle and two triangles. All right. So I got 48.6 degrees. I got 50 degrees. I'm trying to find the height of the pyramid. This is y. This is y plus 5. Or not 5, 20. They're 20 feet away. And why don't you try to solve this one on your own? I would pause the video, try to solve it, and then unpause and check your work. All right, so here I got the tangent of 48.6. It's going to be equal to the opposite over the adjacent. Tangent of 50 is going to be equal to the opposite over the adjacent. So this is y times the tangent of 48.6 plus 20 times the tangent of 48.6 equals x, and then this is x equals y times the tangent of 50. So what you're going to end up with is, I guess I could do the tangent of 48.6 as a decimal. I really would appreciate not doing the decimals just yet, but I can set these two pieces equal to each other since they both equal x. What I would really want to do first is I want to get my variables together. So let me subtract from both sides this y times the tangent of 48.6. So this is like 3y minus 2y equals 1y, right? Same idea. I'm going to subtract these coefficients. I'm going to subtract really these two things. So I got tangent of 50 minus the tangent of 48.6. So this would be 0.0575y equals, and then 20 times the tangent of 48.6, which is 22.686. And then my last step, divide by 0.0575, 0.575, and I would get 394.53 feet, and that's y, right? That's not x, that's y. So I'm not done yet. I still have to take this and write that the tangent of 50 equals the opposite over the adjacent. So if I multiply tangent 50 times that number, I should get x. And that should be 470.18 feet. That's what I was really looking for. I wanted x. So you have to go through all this work, all this hassle, just to not get the answer. But you're a step closer. And then you only have one extra step to do at the end to solve for your variable. So that's some multivariable problems. I would check the answer key that I will post on our classroom page. Make sure that you study for that quiz and email me with any questions.